So the next aspect of chemical kinetics is rate equation. What is rate equation? Rate equation is a mathematical equation that shows the rate of substance in terms of what? Of concentration per what? Unit time. What? Mathematical what? This is a mathematical equation that show rates in terms of concentration of substance with what? With time. Let's consider the reaction below. A react with B to give us what? Small letter, this reaction below. A react with B to give us what? C. And the number of mole of this A is small letter A. Number of mole of this B, small letter B, of C is small letter C. We are now asked to write out the what? The rate equation of this expression. So to write the rate equation for this expression is very easy. It should be what? The rate, which is R, this. This A is the reactant. Don't forget the what? The rules. It should be what? The concentration of what? Of A over what? Time. You put what? You will differentiate what? A. You put the conc of what? Of A to what? Conc of C. You know why we introduce what? Differential equation here? Or differentiation here because it's what? Is the rate equation. So the number of mole we have here, which is what? A, you will divide it by the what? By the rate. And equal to what? The conc of what? Of B over what? The T. What's the number of mole of B? You will put it here. And the conc of C, what's the number of mole of C? The T is small c. Put it here. But don't forget that what? The rate of disappearance or the rate of decrease in what? In A and B is equal to the what? The rate of what? Increase in what? In C. This A and B, they are reactants and they are decreased in what? In size. In order to what? To form B, C. C will be what? Increase in size. Since this A and B are decreased in size, you put minus here, you put minus A, here you put plus here. This is the rate equation for this expression. This is the format used to write the what? The rate what? Equation. Let us solve this example. Write the rate equation of the following reaction. 1. Here we have N2 gas react with 3 mole of hydrogen gas to give us what? 2 mole of Na3, ammonia. 2. Rate equation of SO2 plus O to give us what? 2SO3 2 Write the right equation for this. The third one, we have 3. If you have H2 plus I2, this, we have 2 this. So we are now asked to what? To find the what? The rate equation of what? Of these 3 reactions. Now let us start from the what? Number 1, solution. What do we have? NH2 plus 3H over what? 2NH what? 3. So by applying the what? The rate equation formula, what will be the rate equation here? Rate for this. Apply this formula, please. What is the mole of what? Of N. We have 1 mole. It will be what? Minus D conc of N over what? dt over 1. Because we have 1 mole here. Equal to what? Minus the conc of hydrogen over what? dt. Why we put minus here? Because it's also the what? The reactant. What is the number of mole of hydrogen? 3. Or equal to what? Plus the conc of what? NH3 over what? dt. That is what? The rate equation for what? For ammonia. Formation of ammonia from other process. So the number 2, we have what? 2SO3 plus oxygen to give us what? 2SO what? 3. What will be the rate? The rate will be what? Minus the conc of what? 2SO3 over what? dt. Followed by what? Minus the conc of what? Oxygen over what? dt. Plus the SO what? 3, the what? dt. Number of mole here is what? Is 2. Number of mole here is what? Is also what? 2. So for the third one, which is what? Hydrogen gas, we have with iodide to give us what? Hydrogen iodide. So the rate for this will be what? Minus the H dt equal to the what? Minus the what? I dt and equal to what? Here we have 2. So the plus the H I dt over 2. That is what? How we can write the rate equation of any reaction. And the next aspect of rate of chemical reaction need to treat is what? Is rate law. Rate what? Rate law. So rate law. So the rate law states that the rate of chemical reaction or rate of reaction is direct or is proportional to concentration of reactant concentration of what? Of reactant and each concentration being raised to the power of reaction order. In short, the rate of reaction or the rate law states that the rate of chemical reaction is directly proportional to the concentration of reactants, and each concentration is being raised to the power of what? Reaction order. Take for instance now, if you have N, A, so give us what? Products. The rate law for this reaction is what? It says that what? The rate of this reaction is proportional to what? The concentration of what? Of A to conc of what? Of A. Let me write it mathematically. What is the symbol for concentration? This is symbol for what? For concentration, Abi. So the rate is what? Is proportional. This is proportional symbol to the conc of what? Of reactant. This is the conc of what? Of reactant. What of the reactant here is A. Abi, this N is what? Is mole. And each concentration is being raised to the power of what? Of reaction order or mole. N you have here, you now put it here. Being raised to the power of reaction order, which is what? The number of mole you have what? You have it, you put it here. Remove the proportional symbol. You have rate equal to the what? K, A, N. And this N you have here is called what? Orders of what? Of reaction. This K, where what? K is called what? Rate. Called what? Constant. This K is what? Is rate what? Constant. But assume we have a reaction. Now we have N, A, plus MB. So give us what? Product. How are we going to write the rate law for this reaction? So the rate law for this reaction will be what? Proportional to what? Conc of A, which is N, conc of B, which is M. Change it, we have rate equal to what? K into conc of what? Of A and conc of what? Of B. So this is the rate law for what? For this reaction. Second one. For this first reaction, this is the rate law. For this second reaction, this is what? The rate law. So the rate law states that the rate of chemical reaction is proportional to the concentration of what? Of reactants, and then raised to the power of what? Of the mole of the reaction. The mole of this is M, mole of this is what? Is M. And this K is the rate constant. Sum of this, M and N, yeah. Sum of what? M and what? And N is equal to the what? Order of what? Of reaction. Which is what? Our next aspect of what? Chemical kinetics we are going to what? To treat. The next one is what? Orders of reaction.